All right, so thank you for coming back after that really long example. This one is not as bad because if you look, side A is way bigger than side B. We only have a weird situation if side A is smaller than B, but bigger than that potential height. So it's going to look silly, but it does make a triangle. All right, so let's start with our ground. Then this is our alpha of 80 degrees, so that's very steep. But the side here is B. And then A is going to look something ridiculous like that. Because it is so much longer than B. So we're going to get this really stretched triangle, but it will still make a triangle. All right, so if I have alpha in A and B, then I can find beta. From beta, I can find gamma. And then from gamma, I can find C. So we're going to start with our law of sines. The sine of 80 over 100 equals the sine of beta over 10. So this is going to give us 10 sine of 80 over 100, which yes reduces, which you can do the reduction if you want, or you can just leave it. We'll type it in the calculator. Okay, we want beta by itself, so I'm going to apply inverse sine. And that's the ugly mess we're going to type in the calculator. Inverse sine, again, make sure you're in degrees, of 10 sine of 80, close that, but just on the 80 divided by 100, and then big close for the whole thing inside inverse sine. And this tells me that beta is 5.651 blah, blah, blah degrees. Now remember, in comparison to A, B is a very small side, so the angle should be very small. So getting something like 5.6, 5.7 makes sense here because A is so much bigger and that's going to force C to be bigger. So beta should be tiny. I'm sorry, it does say round to the nearest tenth, so 5.7 degrees. All right, now that we have alpha and beta, we're going to find our gamma. 180 minus alpha minus beta. So minus 80 is 100, minus 5.7 is 94.3. All right, now that we have that, the question is, what is side C? So again, I go back to my A's. So this will be the sine of 80 over 100 equals the sine of 94.3 over C. So C is 100 times the sine of 94.3 over the sine of 80. And you should still see sine of alpha with side A, like on different top bottom of a fraction. So just in case you're like, nah, I'm not sure if I put the angles in the right spot, like double check the side you put is the angle that's opposite that side, opposite that number in the fraction. Okay. So 100 times the sine of 94.3 close divided by the sine of 80 close. And yep. C is 101.256. So 101.3. So looking at our crazy triangle, we had 80 degrees and 94.3 degrees and a little 5.7. The little 5.7 is across from the 10. The 80 is 100 and the 94.3 is only 101. So not that much bigger than A, but both of them are still way bigger than B. And that just has to do with the 94.3 not quite. It's only a little bit bigger than 90. All right. All right, so number 4 here, try it 4, was given an angle, and a side, or sorry, a side, and an angle. Determine the number of triangles possible. So they have given us beta and B and A. So when we draw this triangle, we can't start with alpha in the bottom left corner because our given angle now is beta. So that means over here somewhere, there's our 26. Now, keeping with the way we drew the triangle, we have our angle in the bottom left, the side opposite it, floating around on the right, and then the crane arm, the one coming off of it, is our other given side. So our A equals 31 is here, which makes this alpha, left over up here gamma, left over side is C. This does not want us to actually solve for the triangles, it just wants us to say how many triangles will we get. So our first question is, will this even make a triangle? So if I pretend that 31 is the hypotenuse of a right triangle with an angle of 48 degrees, I want to know, what's that height? That's my minimum. So since B is smaller than A, I want to check, is it too small? Probably not, but so this will be 31 times the sine of 48 degrees. Sine is opposite over hypotenuse, h over A in this case. So we multiply by the A onto the angle we were looking at, so 31 times the sine of 48. All right, so our H is 23.03 blah, blah, blah. So 26 is bigger than our minimum of 23. So we see the triangle we get here, but this 26 is also of a size that we could get the second triangle. So determine the number of possible triangles, 2. And that is because B is smaller than A and bigger than H. All right, so sometimes we give you the ugly triangle, but the question we ask is not that complicated. Or you don't have to show all the work, I guess I should say. What do we have next? All right. Well, we'll do this real quick. It is real quick. So with an oblique triangle, if we want to find the area of it, depending on what we're given, I can construct a height just like I did in the ass triangle above, figure out what that height is, multiply by the base and a 1/2, just using my normal 1/2 base times height triangle. That C sine alpha or B sine alpha would be our H, and then the other one is the third side. Now they give you 3 different formulas here. It's 2 sides and then the angle between the 2 sides. So we have alpha in the formula, B and C are the given sides. So this right here, if I draw a sketch, and C, this is 3.4 feet. This is 7.2 feet. And our beta here is 42 degrees. So I have no clue what the third side is or what either of the other 2 angles are. And law of sines is going to help me here because I don't have angle alpha to go with A or angle gamma to go with C. And I don't have side B to go with angle beta. So I can't figure out the rest of the measures with the formulas I have right now. We're going to see in 5.2, we do have a formula that will let us figure out the triangle here, but this is enough to answer the area. So that height is the sine of 42 is the height over A. So H is A times the sine of 42. That makes C the base. So the formula we get here is 1/2 the base, quote unquote, C times A sine of beta. Now I also could have calculated the height from C, and we would have had C times the sine of 42, and then A would have been the base, and we would still get the same numeric answer, even though the letters would go in the formula slightly differently. So once you recognize that what pieces you have, then you can look up the correct formula. We don't really use this formula that often, just because like you drop the height, using the sine to figure out the height is like something you guys should have practiced in geometry. That is a very normal kind of calculation thing to do. And this area formula just falls out of that. So we don't really like cover it as its own big thing because it's an application of something that we're already practicing. All right, so 1/2 times 3.4 times 7.2 times the sine of 42. So our area is 8.190 blah 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 blah. Nearest tenth, so 8.2. And then this one, they actually gave us measurements. So since this is an area, we can say feet squared, or you could write SQFT, whatever. But since they gave us a unit, we should use a unit. Right. It's a good place to stop.